I've added that. Call user, I've demoed that. And more demos with the user. Vertical character, I've added the repeat. Normal extended basic is this way. Right here. You can only do a call v character or h character. 1, 1, let's say 38. And we want to do it like 55 times. That's normal. RXB is a little bit different. We can do 1, 1, 38, 55, and then we can do 1, 1, let's say 55, 55. As you can see, it did the first command, then it did the second command, so it repeats. Can't do that normal extended basic. A little faster instead of having to use single lines each time. And then we have version. I already showed you this. vget, which is vertically getting a string of characters off the screen, very much like the moves command does. But moves is a little more powerful, but it takes a little more typing to get it to work. vput puts a vertical string on the screen instead of an h horizontal. Like if we were going to go vput, let's say like 10, 10, 496. Now, vput works with, vput and hput work with strings, or, so we can have a string of ABC, or a string variable. It automatically knows if it's a string, or if it's a string variable, or if it's a quoted string. It knows automatically by looking at it. HP is one of the few commands that I've put in there to do this. It's actually pretty smart. And then we have XB. I've already showed you this. And then we're finally down to the last one. We're down to call XB. Now, the interesting thing about this command is this. Let's say we have a program. Like, say we want to load this crash program. And we have a program running. And we insert this line, call XB PG. Now, normally you would do this. Run disk1 or disk1 crash. Now, here's the problem. You want to run this program, but it's too big, so you need to do a call files first. Now, normally you'd have to stop the program, do a call files, do a new. The regular extended basic requires this. RXB requires something a little bit different. Call XB PGM, and we can do our program disk1 crash. But we can add something here that you normally can't do. We have a comma we could put at the end of it, and we can tell it the number of files that we want open. What this does is it'll do a call files, a new, and then load the program. Here it goes. As you can see, it changed the stack memory by doing a call files first. The missing link comes to mind as one of the programs that needs you to do a call files before you run it. This is perfect for loading that. Something that was brought up was about a message that I received by mail. Anyways, here it is, old disk sub goto. This is a program by Barry Trevor for Tiger Cub. Now, in RXB I have call on key, and then we have a string like yes, no, then our key unit, then our key, then our status, then our goto, and then our line numbers, right? Like 200, 300, 400. So here's what I ran into as a problem. The problem being this. With this program, this program does from TigerCub is that you put in a number here for the line number, and then it rewrites this line right here at 32,767 to go to where you want it to go to. The only problem is, obviously, when you renumber the program, this utility right here at this line number will not renumber the line. So you have to find the instances of all the instances of this, or change the variable, so that it changed the line numbers correctly. Now on RXB, for the call key, these line numbers, when you resequence, will go back to the correct number that whatever you resequenced for. It doesn't have this problem that this utility up here does. There's something else. This is a goto. Now there's a go sub version of this right here. It does the same thing as the goto, but like I said, the problem is you can't renumber. So if you want to go sub for on key, go sub instead of on that one, what I did was I said this, look. Sorry. If what we do is, if we go sub 100, then to wherever we want to go, if, you know, whatever, and then where we could go like, go to some other line like 3,000 or 2,000, whatever. But anyways, you see the point. What's going to happen is it'll go sub to 100, that on key. This will go to those keys, and then at like 200, you would have your gobbledygook, whatever you're going to do, and then you have your return. Now, I did write the utility that would do the go sub, but it was in the interpreter and slowed down the interpreter and extended basic. Markedly, you could see the difference, and I said I had to abandon it for that reason. The on-key go-to does not require any change to the interpreter. The go sub does, because it has to put the value onto the stack and then it has to search for it. Because of that, it causes problems. So I had to give it up, and I thought, well, okay, we'll just stick with this. The go sub 100 to that line number works exactly the same way without any overhead on the extended basic interpreter. So this is the way you would do it with a go sub. I just wanted to bring that up because it was something that was brought up to me in an email. One, it explains that normally when you're in pass mode, which is like the bypass mode, that means like it's not loaded to be used. It's just loaded like a regular 32K memory expansion card is. These are the mapper registers and their numbers. Like 2 is the first one. That's at the 2K space or 8192 in hex. And then this is the area where the mapper register is on the card for the AMS card, or in Classic it would be the same thing. There's not a real card there. But this is the address you would find it. Here's the decimal, here's the hexadecimal address. Here's the mapper for the second one. So this corresponds to the memory address. This corresponds to the page that's there. As you can see, 2 is 2, 3 is 3, A is equal to 10, which is equal to A. And then the mapper register is MR10. So mapper register, now as you can see, mapper registers 0 and 1 are not used. Mapper registers 3, 4, 5, 6, 7, 8, 9 are not used either. But 10, 11, 12, 13, 14, 15. And this is the normal pass mode. Now say we want to go into map mode and we want to just throw some numbers in there. Well, you could switch things up. I mean, you can put these pages in these areas of memory. And it doesn't matter which one you pick, because those are the areas of memory you're choosing. So in editor, somebody could do that. In machine language, you can do it. Or in RXB, you can do it too, though it's done a little bit slightly differently, and it's explained in the documents. So this is another switch up where you can just throw any pages anywhere. It doesn't really matter what order they're in, but the memory still works. And then you can switch these pages in and out. Now I wanted to explain something. Each 4K page unit can be engaged in any other section. So you can have 2 pages, like I put 9 in this one, 9 in this one, 9 in this one, 9 in this one. When I write to this area of memory at A, it writes into these others because the same page is there, even though the address has changed. It doesn't know any better. One of the advantages of the AMS card is you can easily duplicate something very quickly, multiple times by writing into one area of memory, and it duplicates in the other areas. It doesn't know any better, so it just does it. So the 32K is used in pass mode, 32K for future use. Now for RXB, 32K is used for future use like this. It's stashed away for RXB future use in that 0, 1, 4, 5, 6, 7, 8, and 9 are for future use. They're not being utilized at all in RXB. So if you want to grow for it, go for it. It's only 32K. Out of a 1.1024 kilobyte card, 1K card, 32K is not much, considering I haven't seen anybody even use a quarter of that memory yet. So 32K is like a drop in a bucket. Until I see somebody use more than, what, 40, 50K, it's not a problem. 4K is going to the rest of the MS. It's used for RXB. So it uses pages 16 to 256 for AMS Bank in RXB. You need 2 pages for the lower 8K. So 2 pages are used each time for the lower 8K. For assembly language support. 8K for assembly language support, lower 8K. Anyways, if this explains how it's mapped out for the numbers systems and how that works. I talked about bload and bsave that take the place of all save or programs that are auto loaders. They have a problem in the fact that they have to load with the program, which means that you have to load another program to get away from them, which is no different than my bsave or bload, other than the fact that it loads multiple ones with multiple pages, which is a more advantageous concept. ISR hooks I talked about, AMS banks where I talked about the pages and how they work are right here, and what I just explained to you. Anyways, that's the latest on this, and I just wanted to give you guys a heads up on all this on the documents. RXB 2012 will be released soon. I just have to finish up a few more things, and then I'll put it out there for you guys.